In this video, we're going to have a discussion with the gentleman from Essex Brakes. I've been working with them for the better half of 13 years. They design, engineer, develop, and support some of the most advanced aftermarket brake systems. They also support race teams. They have incredible know-how and really good customer support in terms of like aftermarket systems. They have a wealth of knowledge and experience that most other brands don't. So we're going to sit down and pick their brains about brake systems in modern cars, past cars, and why you would change your brake system and the caveats of doing so, and just having a life discussion about the enthusiast and car scene. So consider this to be like a podcast format. Sit back and enjoy. So we're here, Jack, with the guys from Essex. We've had a very long relationship with them.
Quite romantic.
Probably too long. Can you guys introduce yourself?
Yeah, I'm Jeff Ritter. I'm the High Performance Division Manager at Essex. My main area of responsibility is everything non-professional racing. So I deal with what probably the bulk of your viewership is, amateurs who are involved in motorsports, take their car to the racetrack, that sort of thing. I've done product management, marketing, advertising, web design, sales, all sorts of different hats over the years in my role here at Essex. And we've built a really great team to support those efforts here. And then Mike
O'Neill. I'm technical director, which is a fancy way of saying I'm in charge of engineering, which is the designs of the brake kits and the dynamometer that we had to design ourselves, and our bedding machines and all the processes we go through for the production of our parts and all that.
How was it, the evolution of the business? Where you guys started and where it is today? What's different, not only in the street car market, but also in the race support system that you guys have set up?
Yeah, I think on the street car market, we've seen a lot of shift. Back when I started at Essex, most cars came with a sliding, very primitive brake system, very small discs. Everything was very basic. So it was very easy to upgrade to something more capable. And over time, stock brakes have gotten a lot better on street cars. So we've had to get more creative, use more advanced materials, more advanced designs, constantly take the high-tech component of the pure racing and bring that to the road cars. So that's changed a lot.
One of the big differences is the street cars actually have quite a bit of electronics involved in the braking systems now, where in racing, most series don't allow nearly as much, just because they're trying to keep costs down and trying to keep cars from getting to where they're going to hit 400 miles an hour on the track. They just certain restrictions that try to keep them from getting too fast.
Yeah, and then on the racing side, I think something that's changed a lot is a lot of the series have gone to spec brake packages, which is different. Like in NASCAR Cup, for example, we had a number of years where everyone was, at each other's throat. It was us and all the other major brake suppliers duking it out, for customers and fighting. And there's been such a push for cost reduction and uniformity. And so that has changed a lot, where it's become a lot more spec brake systems in a lot of series.
I guess before we talk more about the technical sides of the business, we often are asked, what makes brakes competent? What makes a good brake package? You guys are clearly the experts in that space. In your own words, from a technical perspective, what makes good brakes? Because as a journalist or whatever you want to call us, we're like, oh, these brakes feel great, they stop well, but what does that actually mean from a technical perspective on the engineering side?
Well, I think you got to start with the goals first, and the goals that you're trying to achieve here are absolutely consistent brakes. You have to know exactly what they're going to do before you hit the pedal, because if you don't, well, you kind of hit the brakes, see how it reacts, and then make an adjustment. And if you want to turn quick lap times, you don't have time to do that. If you know what the brakes are going to do, if they're very, very predictable and consistent, you can wait later until you can hit the brakes, so you can spend more time at wide open throttle before you do that. But it has to do with temperature management, keeping, brakes do nothing but convert kinetic energy into heat through friction. So there's lots of heat involved. And how we're going to keep things within the temperature range of the part, and that has a lot to do with the sizing of the components. You have to have very stiff components so things aren't flexing on you and you get good feel in the system. That's a big part of the control. You have to have things properly sized for the right balance, front and rear, how much of the braking's at the front and how much is at the rear. And you have to choose the right materials for what you're doing that's going to withstand all those conditions.
Yeah, I think it's thermal management is the big issue.
Can you walk us through, I guess, from a component perspective, what you guys are addressing to add the thermal capacity and the stiffness? When you look at when you look at a brake kit, what parts are you specifically focusing on?
Yeah, I mean, usually when we're doing a design, we start off with, okay, this vehicle, not just what is this vehicle capable of stock, we're looking at what is the typical enthusiast owner going to do with this vehicle? You know, are they going to automatically add 100 horsepower to it? Are they going to throw slicks on it? Are they going to remove weight from it? Are they going, you know, there's a whole string of things that people will typically do with any given chassis. So we take a look at that, and then we kind of say, okay, assuming all those things happen to this vehicle, what kind of thermal capacity do we need really in the brake disc? The brake disc is kind of where we start, right? How much mass, how thick are the walls of the disc going to be? How many vanes did the disc have to have? So we sort of figure out thermal capacity, and then we look at the same thing with pads. You know, how big of a pad will our calipers that we're using now have enough thermal capacity in the pads? Then we look at, okay, how much torque output is there on each end of the car? We have to get those piston sizing and the calipers proper. So that's kind of the exercise that we go through. And Mike's got some formulas that sort of give you, I don't know what you call your secret formula, but it sort of gives assigns a number to a car of what this car needs to be able to handle in terms of heat. And then we kind of work from there with all the componentry to get it down in.
And if you look at a caliper, you know, it has to be very stiff so it's not flexing on you. The more it flexes, the more spongy your pedal is going to feel. And also, you know, cooling. You know, we have the cooling ducts here between the pistons, if you can see that, and flowing all around those pistons to keep them cool, because you don't want to boil the fluid, of course, because that's a quick way to put your car in the wall. If you boil the fluid, the pedal goes to the floor, no braking force left. But I mean, and even like this caliper is set up to run very thick pads at 25 millimeter, and they're very thick not just so that they have a long wear resistance, but the pads also act as insulators between the hot disc and the pistons and the fluid. So the thicker that pad is, the longer that heat path drops the temperature of the fluid.
Yeah, that's a good point on the pad thing. Most stock pads are going to be somewhere in the 15 to 17 millimeter thick range. So that's one of the big things that people kind of trip out on when you show them our brake system and you hand them they get the pads in their hand and they're an inch thick each, and they're like, whoa, they've never seen anything like that. And it's funny because in racing we even go thicker than that. You might have them up to like 30 millimeters, sometimes. So that's always pretty funny to get people to see.
Well, all the heat is generated between the pad and the disc, so it's all created right there. So the bigger the area that you can spread this heat out over, that's going to lower temperatures a bit. And then, but heat works its way off, radiating mostly at high temperatures. Radiation is important, not just the air blowing by and cooling it that way through convection. But heat also works its way through the thickness of the disc, and that's why we have all these vanes here. And these vanes are set up in a way that they will pump cooling air from the inside to the outside and help carry that heat away out of the disc. So more vanes will help move more air, and we'd like to make these pathways to pump more air through there as big as possible. But the bigger we make that, the thinner we can make the walls of the disc, which would make them a bigger, higher temperature rise per brake event if they're very thin. So it's that balance of being able to get rid of heat and also trying not to have big temperature spikes when you do hit the brakes. So we're trying to lower the overall average temperature without having the big peaks.
Yeah, and I think of it like a chain. Like if you have if your disc is running at extreme temperatures, then that's getting into everything else. So then it's going into the pad. It's going into the pad backing plate. It's getting into your caliper pistons. It's getting into your brake fluid, the caliper body. And so all that heat and also associated components like ball joints that are, sitting on the inboard side of this, things like that can get, worn out in a hurry if they're constantly getting seared with track temperature type heat.
It's really easy to make a disc that'll run cool and last forever. Unfortunately, that'll weigh about 120 pounds. So our challenge is to pull as much weight as we can out of it and still have acceptable durability for our customers.
Yeah, so it's when we look at a stock disc, things have changed today where they're trying to design around things like the EPA mandates on brake pad materials, and they can't have certain things in a street compound. So what they're doing is they're making the pad have a huge surface area and the corresponding disc having a, this depth from your ID to your OD being really tall. So they're trying to use radiation to cool the brakes. And what happens when you do that, particularly with the disc, is you're adding a ton of mass. So you're looking at discs that are really heavy and pads that are really big and heavy. So with our components, we're able to pare that down, use different materials, and that gives us a big advantage on weight.
When you move over to the caliper size as well, traditionally, on the OEM side, you can see 10 piston calipers like on a Cayenne. Things, enormous. Why go with a larger caliper? Is it just purely from a fluid perspective? Obviously, you have a bigger amount of fluid, takes longer to heat soak it, I guess. Are you working with larger thermal capacity, or is it the extra pistons are purely from a braking force perspective? Can you walk, I guess, us and a viewer through why you'd want to go from a 4-piston to a 6-piston, what the mechanical advantages and disadvantages of that would be?
Certainly. It really, you got to go back one step. You choose the pad that you need to use for that application to have enough to cover the enough friction area for what you need, is one of the criteria. But then you design around that. And then if you have like a long pad, you need more pistons to be able to get a nice force distribution across that. You wouldn't want a pad that's this long and one piston in the center of it. So that was the evolution as cars have gone up in horsepower and the brakes have had to handle more energy. The pads have gotten longer and they've needed basically more pistons to be able to cover that distance.
And now on the most modern ones, like you look at like a 911 Turbo S, the pad, they've also, in addition to going long, they've gone tall, and sort of what I was mentioning earlier. So then they'll have an array of pistons. It's sort of 2 rows vertically stacked on these giant pad backing plates.
Right, and when you see that, you're looking at carbon ceramic brakes, which have problems with high temperatures, and that therefore they need a much bigger swept area of that pad that will to spread that force over. So not only is it a long pad, it's a very deep pad. So they need, like Jeff was saying, 2 rows of pistons to adequately cover all that area well and get a good force distribution across there. But with the iron discs, we can put more energy per unit area into a pad and a disc, and we don't have to worry about going to a second row yet. Someday, when cars get over 1,000 horsepower, 1,500 horsepower, 2,000 horsepower, yeah, we'll start looking at it then more.
We're about to hit that point with the ZR1, and a lot of the EV products are unbelievably powerful, and obviously they weigh as much as a small building at this point.
Well, I think that becomes the interesting topic, and we're kind of trying to touch on all these little talking points, but the big thing that's changed clearly, and you guys can talk about this a little bit from your careers, is even when we were talking about 13 years ago when we met, cars...
It's very romantic.
Yeah,
we strolled down the avenue. It was wonderful. It was magical.
Yeah, I used all my spent discs and lined them full of candles for our fancy dinners. I think, you go back in time, it's not that far, where cars not only didn't have ultra sophisticated brake systems like today, they had less power, but one of the big things is they were less weight. We've had this argument where brake systems, you go back like the old E92 M3, it had a single piston caliper, right? Like it didn't even have a multi-piston unit. It was just a large caliper, but it didn't have the electronics, and cars didn't have the weight they do today. So not only do you have the power, you have 5,000, pushing 6,000 pound cars. So the braking system not only has had to go up in size.
The thing behind us is like 3,750. I think is what a C8 Z06 weighs.
Yeah.
Thinking that cars were going to get lighter with new materials and advancements came forward, but the customer demand from the OEs has also been for more sound deadening, to make a nicer ride, and more electronics, and the cars have just gotten heavier. So you've got a double whammy here against the brakes, and that you've had increased weight and increased power at the same time. And throw in there too that tires aren't getting any more slippery; they're getting grippier too. But the one thing that's really worked to help us is that wheel diameters have gotten much bigger, and we've been able to fit larger diameter discs in there, basically a little more mass, but more swept area to spread that heat over on the disc.
Yeah, that was always a problem. Like in the old NASCAR Cup, the wheels, 15-inch wheels, and you're trying to just jam way more brake into that wheel than it was ever, intended. And so that was always a battle we fought.
NASCAR was actually the most challenging technically from a brake standpoint for that reason. Large mass, high horsepower, high speeds, and tiny little wheel to fit everything in.
This was a later question. I know Mark and I always talk about this. How are you guys dealing with all the active systems? You have torque vectoring by brake, like in Mark's Type R, which we have one of your kits for. I mean, most of the TC systems in some way use brakes to sort out the car. How are you guys dealing with that? And the addition of, again, like the car behind us, brake-by-wire. All the new M cars are brake-by-wire. The Corvettes are brake-by-wire. How are you working around, I guess, those technical difficulties to still deliver a product today?
Yeah, we have to make sure that we're not going to do anything that hinders those systems. So we have to maintain about the same brake balance as the car is original, hit it as close as we can, and then and right on spec when we can. And then also just make sure that we're not getting the sensitivity too far off. We can't change things from a torque production standpoint at the corners from what the OEs are. And that's fine, because a lot of people think that when they get better brakes means more torque. Well, actually, no. If we put brakes on your car that put out twice as much torque, when you wouldn't be able to control the brake pedal. It'd be too sensitive. You couldn't control the tires with the limited traction.
Your ABS would go bananas too.
Yes.
Like the second you touch the pedal, everything would go, and then it would be a total disaster to drive.
So we have to develop a system that's close in torque put to the original, yet get the advantage of the consistency in there and feel.
So let's talk about this briefly, because I don't want to spend too much time talking about the past braking systems, but where we are today. And Jack mentioned it. A lot of these OEMs now have caught on that their brake systems need to be far more sophisticated. So we mentioned the Type R, right? Because we just went through this car. Brembo two-piece disc design, which obviously can't remove the hat, but it looks like a very, very sophisticated and advanced system for a car like that. But the reality is when you get out there and drive it, because there's so much torque vectoring by brake to get the car to rotate, they're no longer using pure mechanical suspension technique or differential technique to get the car to turn. They're using brake. So what you do is you're heat soaking the system to a point where you're boiling the fluid just from the brake, the electronics. And despite that having a really competent brake system, it doesn't work. So in your regard, and you're talking about this, so if you take a really good Brembo kit, and now you would think, why would you replace it with an Essex kit or a big brake kit, right? Because if you're not increasing the amount of torque, you're actually not, it doesn't seem like it would do anything. So why would I take an expensive brake kit off an OEM car and put your stuff on it? What is it really doing better?
Yeah, I think it comes back to what we talked about earlier with advanced design, advanced materials, those sorts of things. So it's all about cooling. One of our Pro 5000R Radical calipers is much different than what you're going to see on any stock car pretty much. It was designed from the ground up to be extremely stiff, extremely lightweight. It has so much more material removed from it. It has stainless steel pistons, which are ventilated, which is a very rare feature. You do see it on some of the latest really high-end sports cars. It's got anti-knockback springs behind the pistons to keep a firm pedal. There's just a whole bunch of... The cost to do this on a production car is not realistic, particularly on one that costs, $45,000-$50,000. We typically you're just not going to see that. And then it also goes to the disc design, the same thing. To produce this disc with a lightweight aluminum hat, the high vane count, all those sorts of things, it's more expensive. It's got specific metallurgy designed over AP's probably 70 years of making brake discs. So it's crack resistant. It's more expensive to produce. There are just a whole bunch of factors built into this that are far more costly to produce that you aren't going to see. When an OE brake system's got to be, okay, we need to churn out 10,000 of these at a reasonable cost with a reasonable feature set.
Yeah, one specific example, like Jeff mentioned, is the piston material. Why is stainless steel instead of aluminum pistons, which most OE calipers have, important? Well, aluminum is a really good conductor of heat. And in fact, it conducts heat more than 10 times better than stainless steel does. Stainless steel is more like an insulator compared to aluminum. So for a given disc temperature, with stainless steel pistons, your fluid is going to run at a much lower temperature with stainless steel than it will with aluminum pistons. So people think that a lot of times that our systems can run a lot cooler, a lower disc temperature than what the OE system is. And a lot of times we're actually running at about the same temperature or a little higher, but the rest of our system is built to withstand that.
Yeah. So you aren't going to see, and also you have things on the street like dust boots for the pistons. So and a painted caliper. So if you run those features on the track, usually what happens is I've seen them go as little as one day or one track session. I've seen guys are like, oh yeah, by the way, my dust boots around my pistons are completely fried. They get hard, they fall apart. The paint on the caliper turns from a lovely, they used to call them, I don't even know if I should say this, brown bows. Gold Brembo calipers would turn a nice shade of poo brown, and red turns maroon, yellow turns all sorts of awful colors of gray and brown and black. So those types of finishes on a caliper just aren't really designed for track temperatures, whereas something like this, electroless nickel plating, anodizing, those materials or coatings are suited for those types of environments, whereas a painted caliper is just it's gonna have all sorts of problems. You get brake fluid on it, it's gonna bubble and melt and make a big mess.
Yeah, they have to design for a wide range of conditions, including driving through the salty roads of Chicago in the winter.
So I guess to dumb this down, is good braking what you're feeling as a driver? Is it consistency or is it stopping distance? Because a lot of consumers have this thought that if I put massive calipers on my car, it's going to stop in 30 feet less. Obviously, most people don't realize it's a mix of tires and the braking system as well, but what is good brakes, or what are good brakes? My English is breaking down.
The consistency is huge. You want to know what it's going to do every time you're going to hit it. It's going to vary. You want to minimize that variation. And then stopping distance can drop some, and a lot of that comes from now that we have stiffer components and it takes less fluid to activate the brakes. The ABS can react quicker and control quicker.
Yeah, I mean, at the core, really, tires are what stop your car. If you want to get a shorter stopping distance, get a stickier tire. I mean, that's your interface with the road. Brakes, like Mike said at the beginning, the goal of brakes is really to change the spinning disc's kinetic energy into heat and manage that. That's really what your brakes are doing. So we see that all the time. And that sort of leads to one of the big issues. People want to grab the brakes off of car X and slap them on car Y and think that's going to, well, they're bigger. They must, this is going to improve my brake system, when in fact, usually they're going off in the wrong direction. That the caliper pistons have a much greater torque output. It's gonna more fluid. More fluid is required to push those pistons out. The brake pedal is gonna get longer. The torque output is greater on the front end of the car where they did that.
Balance goes away.
Yeah, it messes up their balance. Their ABS goes bananas. Like, it's just a big stream of problems they're heaping on themselves by trying to fit a square peg in a round hole, basically.
I have two follow-up questions to that since we're on that topic before we move on. So conversely, right, you have the ability to, not only you have the engineering knowledge, you have the background with AP, right? You have this long history of metallurgy. Now you're doing computer-aided engineering for all your calipers to an extreme. Obviously, your latest iteration is crazy. But we've had this discussion, and I think, was it with the Brembo, one of the Brembo engineers for Cadillac?
On my favorite car, the Blackwing.
Okay, so a lot of the similar technologies used across the board now in Brembo and like Porsche, big systems. So
Alcon.
Yeah. You guys make brake systems for cars like what we're talking about, Type R, GR Corolla,
Z06, GT3 RSs, everything else.
A huge spread. So after you get to a certain point, it makes a lot of sense how you can improve like a lower budget car, completely transform a braking system where you
like on the 86 we had.
Yeah, I mean, completely transforms it. But you have the argument from the engineers when you get to a higher level of cars that have massive budgets for braking systems. Why would you even consider touching some of these long strand carbon ceramic systems from, again, Cadillac?
Like the new ZR1 or the
Right.
Z06 behind us, they all run big carbon ceramic brakes.
And their engineers are going to argue with you guys, like, why would you touch them? You guys don't have the level of expertise to be even messing with those things. Can you kind of talk through why you would do this and why it's still relevant?
I think it still comes back to, they're having it designed for a wider range of conditions. So yes, they'll do track, but they won't do the track durability of what a system designed specifically for the track can do. What about when you're doing 40-minute plus sessions? That's when you're really getting into the higher temperatures and heat soaked all those components. Where that's different than going out in the track and doing 6 laps and that's about it. So we're and I've worked with some of the OE engineers, and I was telling him once about what the system we did to replace theirs on the track, and he was a bit upset that we would think of even altering his system. But I'm like, we had our discussion. I said, well, it's okay. There's nothing wrong with your system. Your system's designed for a different set of parameters than our system is designed for. It's a different focus. I said, the OEs actually have it more difficult because they have such a wide range of parameters to design for. Their systems are very good for the general customer, but their average customer is not our customer. Our customer is the one that goes out and demands more from the track.
And I think too, it's really interesting when you start looking at the cost of it, the long-term cost of running that brake system. It diverges dramatically between what we produce and, for example, one of the OE carbon ceramics. The Porsche GT car market is one of our most popular. We have tons of guys who get their GT3 RS, and the very first thing they do is buy our iron brake system to install on that car. Usually one of the things we can do is we come closer to the carbon ceramic total brake system weight than we do the iron system that's offered on that car. Usually that has something to do with a big part of that's the caliper. So our caliper weighs 6 pounds and the OE one's 12 pounds. So you start doing the math and you're adding up by corner. And, on a GT3, we're like 30 plus pounds less than the iron system and only a handful pounds more than the carbon ceramic system. So you can get all the, when you look at a carbon ceramic system, the number one benefit of that is unsprung weight. Well, with our system, you can gain that main benefit of the carbon ceramic system without all the pitfalls, problems, and other associated issues. The discs are fragile, and they're going to get chipped by a rock on the track, or they only reach a certain temperature level before you're burning your pads up instantly, or they start to oxidize. And so there are a whole bunch of reasons, long term. And then the other one is our kits are kind of an investment. So we'll have a guy who's got a carbon ceramic setup. If he goes out and burns up those carbon ceramic discs, he has to pay Porsche $30,000 for another set of 4 discs. With ours, they're about $600 a disc, and that's all he has to replace. So you start doing the math on that, and you're talking about, do I want to buy spare discs, or do I want to buy my wife another car, or whatever? It's crazy. The numbers are crazy.
Or if they want to run, racing slicks, they've got to put 18-inch wheels in the car, and the stock brake system just won't fit in there.
Exactly. So you've got a 410 millimeter PCCB disc. Ours is 394 millimeter, fits inside a 19-inch wheel. So you're getting the unsprung weight advantage of the brakes. Then you can also downsize your wheel. So you're going down to a smaller wheel that weighs less. You're getting more unsprung weight advantage. You're getting a whole bunch more tire choices. They may offer slicks in those sizes that they didn't in a 20 or 21 or whatever the stock size is. So that's a great point by Mike. Wheel fitment's usually a big benefit of ours. Our caliper profile is a bit slimmer. If you look at it from the side, we're typically much more compact. The disc size is smaller, so you can fit it. F87 M2 is a great example. A stock car comes with discs a brake system that won't fit inside of 18s. Well, guess what the most popular size wheel is for those cars running on the track? 18. So people rip those brakes off, put ours on, run 18s, and then they're getting all this unsprung weight advantage that you would from a carbon ceramic setup, but you can also run smaller wheels, lighter wheels, better, more tire choices. So there's a whole string of other associated benefits to doing it.
Can we address the carbon ceramic versus iron conversation that we have all the time with engineers? Most track packages, like the car behind us, the new ZR1, run a carbon ceramic. The argument from an OE is that they have the carbon ceramic disc has incredible heat rejection properties that a steel or an iron disc does not. Can you walk us through?
And a longer service life.
Yes.
This becomes the argument with all the engineers from the OEMs.
It's a lifetime part.
They'll never have to replace it. But again, I guess let's straighten out the usage case, right? You guys made the point that a lot of these street cars, they were engineered because they know that most people are not going to track them for more than like 6 to 10 laps, right? They'll do a couple short runs.
That was the Brembo argument about the CT5E Blackwing. GM still charges you a Chevy Spark to replace the discs front and rear. It's $20,000 for a Z06. It's 10 for the front, 10 for the rear, approximately, before pads. But their argument, when I talk to the Brembo guys, is it'll last the life of your car. I don't know what life means in the case of a GM product, but life of your car.
And so that's kind of what we're coming to you guys to clarify, because everybody's telling us they last longer. They're super capable, they're super quiet, their temperature range, they have instantaneous bite in a colder heat range, and they maintain consistency throughout that, where more high performance or iron discs, you got to have the right pad for the right condition, that they're not as flexible in terms of that, and then they're supposed to last forever on namely the long strand carbon discs now. Is that true, and can you explain some of that?
The carbon ceramics are getting better, and make sure there's 3 materials on the track. You've got iron, you've got carbon ceramic, and you've got carbon. And a lot of people confuse carbon, which is a true track-only material, with like you see in Formula One, with carbon ceramic. Very different materials. Other than being black, they're very different. The key word in the carbon ceramic is ceramic. Ceramic doesn't conduct heat very well. Therefore, that's why you see they have the huge surface areas. We've run back-to-back tests on the dynamometer with equal-sized discs, iron with carbon ceramic, and under the same conditions for a brake event, we get a 50% higher temperature rise with the carbon ceramic than we do with iron. So that's why they've got that big swept area, trying to spread out that heat so they don't get as big of a temperature rise. So that's the challenge. As long as you're not getting them too hot on the track, they'll hold up. But a lot of times, if you're doing longer sessions, you're going to get them above those temperatures. You're going to have problems with it.
Yeah. So you're saying, I'm sorry. So you're saying, lifetime. Sure, they're lifetime parts if you're, chasing groceries and, going to Cars and Coffee and driving in the canyons, those sorts of things. You're talking about brake temperatures sub 800 degrees Fahrenheit, probably we're talking about in those scenarios. So what we're talking about, and Mike mentioned a dynamometer, we have a brake dyno here in our building, and he's on it all the time, working with pad manufacturers, working with race teams, working with Indy cars, testing carbon, all those sorts of things. So we've done a lot of scenarios on this. What we're talking about when you're going on a racetrack, and then you're talking 1200 degrees Fahrenheit, 1500 degrees Fahrenheit. What happens at those temperatures when sustained for some period of time is the face of the disc starts to oxidize, and we've seen it with it's chopped fiber, long strand fiber. They still are not able to withstand the same sustained high temperatures that an iron disc can. So they are a lifetime part for the street, and they do have some benefits. We see a lot of guys like, oh my gosh, I have all this brake dust. I what am I going to do? I know people, there are plenty of people on the forums who buy carbon ceramics specifically because they don't want dirty wheels. Fair enough. Like, I'm glad you don't have dirty wheels, but you also have, you have a guy who wants to go to the track. I saw someone yesterday on Redlist. He said he spends 40 weekends a year at the track, right? So that guy, he is not going to be having a good time with carbon ceramic brakes. He's going to absolutely annihilate them, most likely, if he's running, all day, all year long, every weekend. So then he may be the guy with the kind of FU money that it doesn't matter to him, and he can throw 30, 60, 90. He's throwing, hundreds of thousands of dollars at carbon.
GT4 at his braking system.
Right. He's, his brake disc budget for the year is a GT4 RS. Like, sure. But for most people, that's just not sustainable, right? It's like, okay, I need something that's sustainable long term. So, okay, we see typically a guy's going to have a car like 4 or 5 years before they upgrade. They're looking for to try something different. So what our guys do is they'll buy the kit, run it for 4 or 5 years, and they might go through 2 sets of discs, 3 sets of discs, something like that, iron discs. Then when they're done with it, they've got this brake system. They pull it off. They sell it for 65% of what they paid for it, and that really is an investment. They get a big chunk of that back. Their fresh carbon ceramics are still on the garage shelf. They look brand new. The car doesn't look like it was ragged out. They put them on the car, sell the car, right? So it's like when you go to sell your car, do you want to look at your car and you see these destroyed carbon ceramics and you say to yourself, okay, I have to spend $30,000 to make this car presentable to give it to the next guy? Or do I want to make money by selling this brake kit, the Essex brake kit? I can make some money, and I have my brand new carbon ceramics on the shelf. So it's like you're getting money when you sell your car, not laying out tens of thousands of dollars. So that's one of the biggest equations that people don't really think about.
Carbon ceramics have come a long way, and it's advanced very quickly, but it's not quite there yet. I think in 3 to 5 years it will be, and for our uses and for our customers, but we can't supply solutions now based on something that doesn't exist yet. But we keep an eye on it. We keep testing the different materials on our dyno. We're in the loop.
No, I think some of it is. Go ahead, Mike. Sorry.
A big part of it for OE sales is NVH, noise,
vibration or harshness. Yeah.
I mean, carbon ceramic brakes are very smooth, like you said, and quiet, and they're absolutely wonderful in the street.
Yep, and I think, a lot of people demand that. Like I said, there are a lot of people that just want clean wheels, or they just don't want their brakes to squeak when they're out on a date because they're embarrassed by that. Whatever it might be, but that is a real thing, and a lot of people, they don't need to be able to thrash them all day on a racetrack. So I think they are a good product for a lot of owners.
And I think part of it's visual.
Yeah.
People like the way they look on the car, and you can actually drill holes in carbon ceramic brakes and not have that cause cracks.
Right.
So.
Yep. So you can fill a wheel up, a 21-inch wheel. Yeah, it looks great with big yellow calipers and a 420 millimeter disc with 410, whatever. So there are a lot of good reasons to do it. But the reasoning that they're better on the racetrack and it's a more viable long-term solution for that environment, at this point today where we are with their development, we don't believe that's the case.
I just wanted to kind of follow up on that, because when I'm just hearing this conversation and I'm kind of removing myself from, let's just pretend we're normal people, that for a minute from the outside, this sounds absolutely batshit crazy, this conversation. You know, the concept of buying a car that is, let's just say $100,000 or more, and then you have a brake setup that's going to require you to spend $30,000 on replacement brakes. I mean, this is just insane. And then not only, think about this for a minute. You bought that car, you have $30,000 worth of brakes, and then you're going out to buy another brake kit to replace that one so you don't mess that one up as a proactive cost savings measure. I mean, being a car person has got to be one of the dumbest things.
I tell people that. I have conversations with people and they're like, what do you do? You know, and we'll talk about it. And they said, well, how much do these brake systems cost that you're selling? And I tell them, they're like, wait, people pay that much for this? And then I explain to them, like, well, if they don't, this is what they have to do. You know, how would you feel if you went in and, you know, they said, we're going to do a brake job and it's $30,000, and the people they don't believe you. They're like, what? This can't be real. It's so true.
A lot of our customers who have track experience now, you know, purposely when they go to buy a new car, they do not get the option with carbon ceramics because they know that they're paying for something that they can't use for the track.
Yeah. The only reason a lot of them do it's the whole resale thing, right? Everyone buying cars they're speccing it for resale, not for their own enjoyment, you know?
I'll continue on the next part, that is, with all these talks of these different brake systems and even the concept of replacing your brakes with a brake kit. One of the things that I found over my short time of dealing with this is there's so many different brands that offer kits or upgrades, and oftentimes these aftermarket companies, they'll sell you something and they wind up being disposable. When they break, you can't get support, or you just buy something new. And you guys are completely different. You're one of the rarest in the aftermarket world that not only produce highly engineered and very technically proficient brake setups, but you guys have the facilities to support it, clean it, you're testing them, you have all of this know-how. And can you explain that a little bit for people, how important it is in this era?
Yeah, I think when we started the program, one of the concepts was this has to be sustainable and supportable, because being someone who took my car to the track many times over the years, I've been through that, and all my friends have been through that. You know, you call someone up and say, hey, I need spare discs. But no one ever calls you back, or there's not even a phone number to call, period. So one of our concepts was sustainable. You know, we're always going to have someone on hand to pick up a telephone if you call during business hours. And then on the development side, yeah, we have all the tools. We've got people like Mike who have been in the business for 40 years?
30. Don't push my
30. Okay, yeah, 30 years. My bad. Who have worked at the highest levels of racing. You know, he's been the head judge for Formula SAE many times. Those people of that caliber working on this from the beginning, doing the designs, using finite element analysis, using our brake dynamometer to test things to make sure that the quality of the parts that we're selling to, you know, the average enthusiast with his Corvette are the same level as what we're selling to all the NASCAR Cup teams. We've got a full-time quality control engineer. We've got a coordinate measuring machine. We've got laser scanners. We've got 3D printers. So we have a huge investment in making these components.
We're not just machining brackets and hats.
Yeah,
More goes into it than that.
Right. So there's a whole. We have 30 people on our team right now. So there's a whole group of people that all we do all day, every day is work on these problems, work on improving the product continually, work on supporting someone who purchases one of our products. So yeah, they're not going to be hung out. And we also have a warehouse with millions of dollars of spare parts in it. So if you call us on Thursday when you realize you're putting your brake pads, you know, you're putting your car together to go to the track tomorrow, and you're like, oh, I don't have any, whatever it is, brake fluid, brake pads, you can call us and we can overnight something to you from our warehouse because we hold a huge inventory of spares.
And how many times have we been answering customers' questions on Saturdays and Sundays while they're at the track?
Yeah, I mean, I get texts from people like, I have a weird vibration, whatever. And so, you're texting with someone, that sort of thing. But that's kind of the level of service that we try. So we've got a really great internal team here. They're all enthusiasts. They're all very eager to help the customer and put the customer's needs, first.
Yeah. Or if they're running our systems, if they're running our brake systems and they're throwing out the stock booster and they're going to a parallel dual master cylinder setup with a balance bar, what size master cylinders they need to run, and we'll help them size that and get them figured that out depending on what pedal assembly they're running. That can change it, and there's many variables involved there, especially when they start adding wings and all these other things.
As we sort of wrap up this interview, I guess my last sort of two questions in one is we introduced you briefly in the beginning of this. Can you walk us through how you both got to where you are, sort of your history with cars, and as someone who, I guess I'm no longer young, but it was once young, how do you actually get into the industry that you're in? Obviously, we're very privileged when we get to interview chief engineers, assistant chiefs, people on the V-dyne side, chassis side. You guys are not in a traditional OEM role, but you get to do something that's a dream job for many, many people. Obviously, I did SAE in college as well. How did you get to where you're at today?
Well, I started out in a family that raced on two wheels and motorcycles, and did a little bit of that when I was a kid, and helped friends working on their cars and late models and stuff. And then when I went to the University of Akron, where I got my bachelor's and master's degrees in mechanical engineering, and I was in charge of the Formula SAE team there as a team captain. And that's all sounds like, oh, that's all engineering stuff, but there are many positions you can do on the Formula SAE that are marketing and sales based and other things. So it's not just for engineers. There are other positions you can hold there. And that, all my work there, and in combination with my experience autocrossing and working on late models and other things like that and road race cars, got my first real job in the industry, which was Tilton Engineering, where I was chief engineer there for 15 years before I took the good opportunity to come to Essex, and I've been here 15 years since. I still work with Formula SAE teams. I judge at the competition. I lecture to students on brake system design and team management and things like that. I still race motorcycles. I'm a flat track racer. Sometimes I race in the class where they allow brakes. Sometimes I race in the class where brakes are illegal. So that may seem like a contradiction for an engineer. You do still have brakes, just not the typical friction type. We're doing it through tire scrub.
And your feet, right?
Well, when all else fails.
That's right.
My God. I guess on the engineering side, I'll approach it from, coming from that background. Is it when you talk to a young engineer in university, typically you'll get freshmen or sophomores like, hey, I don't know what the hell I want to do, but I don't know how to get there, but I want to work on cars in some capacity. What do you tell them from your advice? Obviously, you talk to far more students than I do. What do you tell someone who's in that spot?
Oh, get involved on a team, Formula SE, Baja, any of those. And there are so many opportunities of different things to work on. And just by working on one thing, you're going to learn whether that's what you like or if you want to work on something else. It's a learning experience. And the interesting part of those programs is you're not going to take classes and learn everything you need to learn. You're not going to take any classes in school on shock tuning or anything like that. You're going to have to teach yourselves. And that's one of the signs of a good engineer, and in other professions as well. You don't graduate with having all the answers to everything. If you're really smart, you've learned how to ask the right questions and break complicated problems down into many smaller, simple problems which can be solved.
Actually, I was a bio major. I thought maybe I wanted to be a doctor, and then I was one of those people that got weeded out by organic chemistry. It was like my only C ever, and I knew it wasn't my life going forward. So I got a ride in a 911 on Watkins Glen during a parade lap, and I thought it was one of the coolest things I had ever experienced. So like that Monday afterwards, I was out shopping for a car. So I bought a 98 Integra Type R, started autocrossing it, tracking it as a hobby. And then I ordered a 350Z in 2002, and I contacted StopTech to see if they were going to make a brake kit for it. Turned out I was talking to the owner of the company. We chatted. I was so busy at work. I was working in a marketing research company for consumer packaged goods. And I was spending all my days looking at car stuff on the internet instead of doing what I was supposed to be doing. Had exchanges with the owner of StopTech, offered to do some work for free for him. I wrote some things for him, some press releases and things. And then like after staying in touch with him for about a year and helping him out on some things, he just called me up out of the blue one day and was like, hey man, we're growing. I need you to fly to California. I really want you to come work with me. And so yeah, I got into it that way. And then I worked there at StopTech, and we grew from, very tiny kind of startup. We were bought by a bigger company. We were growing at crazy levels over the years I was there. Got some OE type contracts, that sort of thing. And then I wanted to move back to the East Coast to be closer to all of my wife and I's family, have kids, that sort of thing. So the opportunity came to my attention, and that Essex was looking for someone to build a aftermarket program, sort of like what we had at StopTech. So
then you had to start all over again.
Yeah, so then I had to do it again. But the second time is much easier than the first time because you kind of know what to do already, right?
So what would you then ask someone who's younger? Like if you're coming from a business background or an econ background, or maybe not from the nerd perspective in the more traditional sense, if you were to grab someone at a university or a high school, what would you tell them to, like, hey, you want to work on cars, this is how to do it?
Yeah, I think for me the thing is persistence. And I look back like that experience I had with the owner of StopTech. I was like, have you thought of this? Have you thought of this? Have you done this? And he was like, hey, that's a pretty good idea. Don't be afraid to offer ideas. Like when I interview someone, we've hired a whole bunch of people here. When I interview someone, I want them to tell me specifically. They'd be like, hey, I was on your website and I saw this. Have you ever thought about doing this? I have some really great ideas about that. I mean, that's what we want. If we're going to hire you, that's what we want you to do. I don't want you to come sit here and wait for someone to tell you to do something. So I would say the biggest things are, be proactive. And when you submit your resume to a company, you should know everything you can possibly know about that company if you want to work for them. That bothers me as much as anything. When someone will, they'll have a generic objective on their resume, and it's sort of like, I want to work in a company to use my skills. I want specifics to say, I saw what you're doing with your product. I think you could do this, 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 and it will be that much better, and here's why. To me, that is far more valuable, and that's what we want out of our employees, people that want to get in, make an impact, and do something. So for me, it's persistence. It's tailor your presentation to the company that you really want to go for. Make sure that company's their sort of mission statement aligns with your personal beliefs or your mission. Work for a company that you can be proud of the product you're working around, that sort of thing.
There's so many race teams out there looking for help, whether it be on the technical side, on the hospitality side, or whatever. They'll be glad to have you, and so that you can get the experience.
Yeah,
that's the best way to get that experience for the resume, and just to really discover what you like and what you might like even more.
So I'm just going to close this out. I really appreciate your time, guys. Thank you for taking the opportunity to talk about yourselves and Essex, and just kind of fill in the gaps here.
And put up with us.
Put up with us after all these years. We're trying to show the light of the people that are actually good at what they do, companies that actually have their shit together and that are good to customers and that stand the test of time. And you're definitely very, very one of the small groups. So thanks for hopping on this.
Thank you.
Appreciate that. Thank you.
Yeah, thanks, man. I really appreciate the channel. Our staff here internally, I don't have a lot of bandwidth personally and I'm also somewhat jaded, as you guys I'm sure are, with the car thing overall, right? Like I have McLarens parked in the back and I'm like, oh, that's a nice, carbon fiber McLaren. It's like, people are like, oh my God. But there's so much out there now. There's so much content. There's so many things hitting you all the time, and you guys do an awesome job of focusing on, you know, what real enthusiasts want to see. You guys dig deep on the technical side. You talk to people at OEMs. And it's funny, like now, I always think to myself, if I'm considering my next sports car, I'm like, do Mark and Jack like this thing? And I'll go find your video on, even if it's like something for my wife or my daughter. I was shopping for a car for them, and like an SUV, and I was like, oh, I need to see if they did a video on this. And I'm pretty much like, all right, if you guys sign off on it, I'm good. Like if you guys, you know, if it's not passed, it's not going to pass for you, then I'm usually like, all right, it doesn't sound like it's for me. So you guys are kind of my benchmark meter for figuring out whether it's a good fit for me. So yeah, I love your channel and love what you guys do. So please keep doing it. Yeah.